Solving systems by elimination. You can use the elimination method to solve a system when one of the variables has the same coefficient in both equations. The elimination method is as follows. Step 1, multiply one or both equations by a number to result in two equations that contain opposite terms. Step 2, add the equations eliminating one variable, then solve the equation. Step 3, substitute the value from step 2 into the original equation to find the other variable. So in this example, we're going to solve the system and check our solution. So as you can see, the x terms both have a coefficient of 3. And in order to solve by elimination, they have to have opposite signs. So what we're going to do first is multiply the entire second equation by -1. And I could have chosen to do this to the first one, but I went with the second. Either one, it doesn't matter. So when I have completed that task, I would have my original equation 1, 3x minus 4y equals 2, and my revised equation 2 is now negative 3x minus 2y equals negative 26. Now we're going to add the two equations together. So 3x plus 3x is 0. Negative 4y plus negative 2y is a negative 6y. 2 plus negative 26 is a negative 24. Again, it's called the elimination method because, as you can see, I have eliminated x from the situation currently, so I can focus primarily on y. So the next thing I would have to do is divide both sides by 6 to get y by itself, and I would get y is equal to 4. Now I would take this value and substitute it back into equation 1 and find x. So I have 3x minus 4 times y equals 2. So again, we now know y is 4. And I'm using equation 1, as you can see. So I would now have 3x minus 16 equals 2. Add 16 to both sides. You get 3x is equal to 18. Divide both sides by 3. You would have x is equal to 6. So the solution to the system is 6, 4. Always put x before y. Don't forget that, folks. Always put x before y and write it as a coordinate or ordered pair. So now we must check our solutions. So 3 times 6 minus 4 times 4 should equal 2. 3 times 6 is 18. 4 times 4 is 16. And 18 minus 16 is 2. So that is correct. Check it with the second equation. Again, 3 times 6 is 18. 2 times 4 is 8. 18 and 8 make 26. So yes, this is definitely a solution. It satisfies both equations. All right, Now in example 2, neither of my x or y variables have the same coefficient. However, when I look at the y terms, I have a coefficient of -3 and a coefficient of 6. I can easily make 3 turn into 6 by multiplying it by 2. They already have opposite signs, so that's great. So the only thing I need to do is multiply the entire first equation by 2. So when I do that, I would have 6x minus 6y is equal to 42. Bring down equation 2 as it was written. And now I can add my equations. 6x plus 8x is 14x. Negative 6y plus 6y cancel each other out. And 42 plus negative 14 is 28. Divide both sides by 14 to get x by itself, and x is equivalent to 2. Now we take x and substitute it back into one of the original equations, either one, it doesn't matter. So let's use equation 1 since it has smaller numbers. So that's 3 times x minus 3y equals 21. Again, x is now 2. So 3 times 2 is 6 minus 3y equals 21. Subtract 6 on both sides, you would get negative 3y equals 15. Divide both sides by negative 3, you would get y is equal to negative 5. So the solution to this system is 2, negative 5. And check to make sure that it works. It works with the first equation. And the second. So good job, guys. Now the equations are getting a little tougher. When I look at my x terms, I have a coefficient of 2 and a coefficient of 5. When I look at my y terms, I have a coefficient of 3 and a coefficient of 7. So we're going to have to multiply both equations by something to get them to be coefficients with to have the coefficients be the same number with opposite signs. It doesn't matter, just make a decision. You can choose to eliminate x or choose to eliminate y. I'm going to go with x because it has smaller numbers. So what does 2 and 5 both go into? 10. So let's make the first x positive 10. So that means I would need to multiply it and the entire equation by 5. Now I would have to make the second x term a negative 10. So that means I would need a negative 2. So now I'll rewrite the new equations. So new equation 1 would be 10x plus 6y. Sorry, rewind. 10x plus 15y equals 35. Again, multiplying everything by 5. The new equation 2 would be negative 10x minus 14y equals negative 30. Now add the two equations together to eliminate x. 10 plus negative 10x, 0. 15y plus negative 14y is simply just 1y, or y. And 35 plus negative 30 is 5. So that was very nice and easy to solve for. Now we know what y is. Go back to one of the original equations. So let's go with equation 1. And we're going to substitute y in with 5 to find the solution to x. So 2x plus 15 equals 7. Subtract 15 on both sides. You would get negative 8. Divide by 2 on both sides. You would get x is equal to negative 4. So the solution to the system is negative 4, 5. Check your work. You never have to ask Miss Perry if you got it right. You simply plug the solution back in to your equation and check your own work. So it works in equation 1. And it works in equation 2. Now practice these two systems on your own, and don't forget to check your solutions. Now here comes the dreaded word problems. We're going to write and solve a system described in the situation. To raise money for new uniforms, the band boosters sell t-shirts and hats. The cost and sale price of each item is shown. The boosters spend a total of $2,000 on t-shirts and hats. They sell all the merchandise and make $3,375. So first and foremost, we have to assign variables. So let T represent t-shirts. Keep it simple. And H represent hats. So it costs $6 per t-shirt and $4 per hat, and they paid an original cost of $2,000. So that means we would take 6 times T plus 4 times H, and that would equal 2,000. That was the original cost that they had to pay to buy the merchandise. Then they charge $10 per shirt plus $7 per hat and made $3,375. So that those two equations would represent the system right there. So take the cost of each item times the number of items, which we're going to figure out in just a moment. Now that we have our system, to solve by elimination, I would need T or H to have the same coefficient. So let's go with H. 4 and 7 are the coefficients, so 28 is what both 4 and 7 have in common. So let's make 4H become a positive 28 by multiplying everything by 7. And We'll make 7h become a negative 28 by multiplying it by a negative 4. So the new equations would be 42t plus 28h is equal to 14,000. The new second equation would be negative 40t minus 28h is equal to, and I need to grab my handy dandy calculator for that one. My brain is shot. 3375 times negative 4 is negative 13.5. Now we add the two equations together. So 42t plus negative 40t is 2t. 28h minus 28h or plus negative 28h is 0. And then 14,000 plus negative 13,500 is 500,000, or 500, sorry. And now divide both sides by 2, so t is equal to 2250. So they sold 250 t-shirts. Now let's find out how many hats they sold. By taking 250 and substituting it back into the problem, the original equation. So 6 times 250 plus 4 times h is equal to 2,000. Again, t is 250. 6 times 250 is 4 quarters and $1. $1.50 plus a 0. So 1,500. Subtract 1,500 on both sides. You get 4h is equal to 500. Divide both sides by 4. H is equal to, is it also 250? Let me double check. $125. Sorry, guys. While I'm at it, let me double check my mathematics on that other one. Oh, yeah. Okay. So they purchased 125 hats and 250 t-shirts. This concludes your lesson for today.